$12 billion. That is what Waymo, Cruise, Argo AI, and Apple's Project Titan collectively burned through between 2015 and 2023, not counting the hundreds of millions more absorbed by Aurora, Zoox, Motional, and a dozen smaller programs that dissolved quietly and without obituary. $12 billion, and the American consumer still cannot summon a self-driving car to their driveway on demand. Not in most cities. Not reliably. Not in rain. The spine question, the one this entire video orbits, is not whether the technology works. It is why the richest engineering culture in human history handed effectively unlimited capital and the most talented pool of roboticists and machine learning researchers ever assembled in one geography, produced something that a cab driver in Shenzhen can now do on a production budget. That gap is not a technology story. It is a story about what Silicon Valley believes about the world and where that belief system, powerful enough to reshape communication and commerce, runs directly into physical reality and loses. The error that almost every piece of coverage on autonomous vehicles makes is treating this as an engineering problem that is nearly solved, a few software patches away from mass deployment. You have seen the headlines. The framing is always temporal, a matter of when, not whether. And that framing is wrong, not because the engineering is impossible, but because it misidentifies what the actual obstacle is. The actual obstacle is that Silicon Valley designed a solution for a world that does not exist, and then spent a decade surprised that the real world kept failing to cooperate. Here is what the dominant narrative consistently omits: the most successful autonomous vehicle deployment in the world, measured by units on the road and kilometers driven commercially, is not happening in San Francisco or Phoenix. It is happening in Wuhan and Shenzhen and Guangzhou.
And it is being run by companies Baidu Apollo, WeRide, AutoOx that were dismissed for years as derivative copycats of the American pioneers. No, actually, that framing is itself the mistake I am trying to correct. They were not copying. They were building differently, for different assumptions at different cost structures, under different regulatory conditions. The gap between what American autonomous vehicle companies spent and what they delivered is not evidence that the problem is hard. It is evidence that the American approach to the problem was, in a specific and traceable way, wrong. Let me be more exact about this, because the difference matters. In 2017, Waymo, which had at that point been operating since 2009 under Google's umbrella, announced that it had completed 4 million autonomous miles. The press coverage was triumphant. 4 million miles. The team was extraordinary. The hardware was state-of-the-art. Chris Urmson, the founding technical director who had left a year earlier, had built something genuinely impressive. And then the number kept growing. 8 million, then 20 million. By 2022, Waymo had completed over 20 million miles of autonomous driving. And its commercial robotaxi service, Waymo One, was operating in parts of Phoenix and San Francisco. Geofenced, limited, available to a waitlist, not profitable. 20 million miles and a waitlist. Now, hold that number, because in the same window, BYD, not an autonomous vehicle company, a car manufacturer, sold over 8 million electric vehicles in 2022 alone. Not miles driven, vehicles delivered to customers at a price point that made them accessible to a middle-income buyer in China. That comparison is not entirely fair. They are different industries solving different problems, but it exposes something real about what Silicon Valley optimized for. The American autonomous vehicle companies optimized for the demonstration, for the milestone, for the funding round.
And the funding round rewarded the milestone, not the delivery. This is the specific mechanism. Venture capital, by its structure, rewards proof of concept at scale. A company that can show 20 million autonomous miles raises its next round. It does not need to show a profitable route. It does not need to show a unit that costs less than $200,000 to manufacture. It does not need to show a vehicle that works in a construction zone in Detroit in February. It needs to show the miles, because the miles are what the next investor can put in a deck. Travis Kalanick, when he was running Uber, said something in 2016 that was later quoted in court documents from Uber's lawsuit with Waymo. He believed that self-driving cars were existential for Uber, that if Uber did not have its own autonomous fleet, it would be replaced by whoever did. He was not wrong about the logic. He was wrong about the timeline. And the timeline error cost Uber's Advanced Technologies Group roughly $2.5 billion before the entire operation was sold to Aurora in 2020 for $400 million. That is not a rounding error. That is a $2 billion miscalculation, built on a timeline assumption that almost every major player in the space shared simultaneously. And this is the part that, okay, I find this genuinely strange. Every major autonomous vehicle program in the United States made roughly the same timeline error within roughly the same 3-year window. Think about that for a second. Not one company, not two. All of them, simultaneously. Waymo's internal projections from 2018, which became public through litigation, suggested widespread commercial deployment by 2020. Then 2020 came and went. GM Cruise received regulatory approval to deploy driverless vehicles in San Francisco in 2022, then suspended operations in 2023 after a pedestrian collision triggered an investigation that found the company had withheld information from the California DMV.
Argo AI, backed by Ford and Volkswagen to the tune of $6 billion, shut down entirely in 2022. Not pivoted. Not acquired for a premium. Dissolved. Ford and Volkswagen took the assets and walked. You are watching 3 of the best-funded technology programs in modern history fail in the same way at the same time, after making the same prediction. So the question that never gets asked loudly enough, did they all make the same error independently? Or were they all responding to the same incentive structure in the same way, and couldn't afford not to? Here is the documented fact layer. The primary technical challenge in autonomous vehicles is not highway driving. It is edge cases. The unpredictable, low-frequency, high-consequence situations that a human driver handles through judgment. The child running between parked cars. The construction worker waving traffic through a closed lane. The driver ahead braking erratically because they are looking at their phone. The pothole that is invisible until you are already in it. These are not hard problems because the sensors cannot detect them. They are hard because handling them correctly requires contextual reasoning about human behavior. And that reasoning, in 2023, still requires either enormous compute, enormous training data, or both. The Rand Corporation published a study in 2016, before the peak spending years, estimating that to demonstrate autonomous vehicle safety at a statistically meaningful level, you would need to drive roughly 11 billion miles. 11 billion miles. Waymo's celebrated 20 million miles is less than 0.2% of that threshold. Less than 0.2% of 1%. Now, my inference, not a documented fact, I think the timeline error was not a mistake. I think it was a strategic choice that the funding environment made rational. Here is what I mean. If you are a company in 2017 raising a Series B on the strength of your autonomous vehicle program, you face a choice.
You can tell investors this will take 20 years and cost more than any single company can fund. Or you can tell them we are 2 to 3 years from commercial deployment. The first answer kills your round. The The second answer, which multiple executives under oath have since admitted they did not fully believe, gets you funded. And once you are funded, you can keep working on the actual problem, which is hard and will take 20 years. The lie becomes load-bearing. This is not speculation. This is the structure of how venture-funded technology companies relate to timelines in competitive spaces. It happened in nuclear fusion. It happened in Hyperloop. It is happening in certain corners of quantum computing right now. The difference with autonomous vehicles is the capital involved and the public safety implications of getting it wrong. Here is the dark observation, and I say this as someone who finds the technology genuinely fascinating. The most honest account of where autonomous vehicles stood in 2021 was probably written not by Waymo or Cruise or any of the companies spending billions on the problem, but by the National Highway Traffic Safety Administration, which published regulatory language stating, essentially, current levels of automation require a human to be ready to take control at any moment. The government's official position in the same year that multiple companies were announcing commercial robotaxi services was that automation still required a human backup. The billions were real. The cars were real. The backup driver was also real. Here is a question I have been sitting with for a while, and I don't think it gets asked seriously enough. Suppose the American autonomous vehicle industry had been structured like the Japanese automotive industry in the 1970s. Long capital horizons, patient institutional investors, supply chain integration, no pressure to demonstrate commercial viability in a venture fund's 8 to 10 year window.
The historical precedent is Toyota's development of the hybrid powertrain. Toyota began internal research on the Prius drivetrain in 1993. It launched commercially in 1997, 4 years by a large industrial company with full commitment to production. Not demonstration, production. Under a patient capital model, would American autonomous vehicle companies have made different choices? My read, yes, almost certainly. The specific choices that burn the most capital. Redundant sensor suites designed to impress investors rather than minimize cost. Geographic expansion before the core technology was stable. Marketing timelines that were disconnected from engineering reality. Those are not engineering decisions. Those are fundraising decisions dressed up as engineering decisions. Here is the other question, the more uncomfortable one. Suppose Cruise had not been acquired by General Motors in 2016 for approximately $1 billion. Suppose it had stayed independent. Would a leaner, hungrier Cruise have made different safety calls in San Francisco in 2023? I genuinely do not know, and I flag that clearly. But here is what I do know: when GM acquired Cruise, it inherited a startup speed and attached it to a public company's obligations, quarterly earnings, regulatory exposure, shareholder expectations. That is a structural pressure to deploy before you are ready, not because anyone is malicious, because the clock is different. And the clock, in this case, may have mattered enormously. So, why could $10 billion in Silicon Valley not build a car? The partial answer, the one you now have that you did not have before, because $10 billion in Silicon Valley was not trying to build a car. It was trying to build a demonstration of a car that attracted the next $10 billion. The product was the funding round. The car was the collateral. This is not a moral indictment. It is how the system works.
And the system produced extraordinary things. Real technology, real talent, real progress on the fundamental problem. But it did not produce a car you can hail in Cincinnati. Here is where I will tell you where the evidence leads me personally. I think the question of whether full autonomy is achievable, level 4, no human backup, commercially viable at scale, is genuinely open. Not in the way that fusion is open, where the physics works but the engineering is brutally hard. More open than that. I think there is a real possibility that full autonomy at mass market scale requires a level of AI reasoning that we do not currently have and cannot currently predict. I think the people who are most certain it is coming in 5 years are working backward from the funding they need to raise. And I think the people who are most certain it will never happen are not accounting for how quickly the underlying machine learning capabilities have moved in the last 4 years. The majority view in technology journalism that autonomous vehicles are inevitable and we are arguing about timing strikes me as too confident in one direction. Not because the technology cannot work, but because the cost and complexity curve for the last 20% of edge cases may not be linear. It may be exponential. And if it is exponential, the economics never work. There is also an unflattering observation about that majority view. It is almost entirely produced by people who have never had to drive in a city where the road markings have faded, where the traffic signals are timed for a flow pattern from 1984. Where 3 lanes merge into one because someone illegally parked at the intersection. The technology demonstrations happen in Phoenix and San Francisco and Mountain View, cities with good infrastructure and warm weather and relatively predictable traffic behavior. The gap between works in Scottsdale and works everywhere is not a software patch.
If this landed differently than you expected, if the frame here is useful, the most useful thing you can do with it is send it to someone who works in infrastructure, in urban planning, in transportation policy, not because they need to be convinced of anything. Because the decisions being made right now about how cities design roads, what sensor infrastructure gets built into new construction, how regulatory frameworks get written, those decisions are being made on a timeline assumption that the evidence does not support. And the people making them often have not been told that. Here is the specific underreported risk. The capital that was concentrated in American autonomous vehicle companies is dispersing. Argo is gone. Cruise is suspended. Several of the researchers have moved to robotic startups, to defense contractors, to companies building autonomous systems for warehouses and ports, not roads. Some of them have moved to China through talent acquisition programs that are documented by the National Counterintelligence and Security Center, which has specifically flagged autonomous vehicle expertise as a technology transfer risk. To be clear, this is not a story about loyalty or betrayal. When a $3, $6 billion program shuts down overnight, engineers go where the work is. That is rational. That is human. The problem is structural. The country that funded the research did not build the conditions to keep it. The technology built on public roads, with public data, funded partly by regulatory goodwill and partly by the tolerance of American cities that let these companies operate at scale, that technology and the people who built it are now redistributing globally. The expertise is not staying in the zip codes where it was funded. Meanwhile, in Wuhan, as of Q1 2024, Baidu's Apollo Go robotaxi service is operating commercially, without safety drivers, in a geofenced but expanding zone of roughly 500 square kilometers. Not a demonstration. Revenue-generating trips.
A volume that American companies said they would reach by 2020. So here is the question I cannot answer, and neither can you, and neither can anyone who will tell you they can. If the country that invented the technology ends up a permanent customer of the country that deployed it, not in semiconductors, not in social media, but in autonomous mobility, which will eventually touch logistics, defense, and the physical movement of every city on Earth, what exactly did $12 billion buy? $12 billion. Not $12 billion invested in something that works. $12 billion invested in the idea of something working. That's the whole story, honestly. And I keep thinking about it because it's one of those situations where the punchline is real life. The part nobody says out loud here is what actually happened with autonomous vehicles in America. The companies didn't fail because the engineers were bad. The engineers were extraordinary. MIT, Stanford, Carnegie Mellon, the best robotics minds of a generation, all in one place, all working on one problem. They failed because the product was never the car. The product was the pitch deck. The car was the thing you showed during the pitch. Think about that for a second. You raise money by promising a timeline. The timeline gets you funded. The funding keeps you alive long enough to raise more money by promising another timeline. And the car? The car is basically a prop. A very expensive, very sophisticated prop that drives itself around Scottsdale, Arizona, in perfect weather on roads that were repainted last Tuesday. My personal read, and it's not flattering, I'll be honest with you. When I first looked at this story, I thought it was a technology story. Hard problem. Smart people. Takes time. Then I looked at Waymo's numbers. 20 million miles driven. 20 million. And their commercial service had a wait list. A wait list. For a product that's been in development since 2009. That's 15 years.
Meanwhile, BYD, a car company, not a tech company, sold one. 8 million actual cars in one single year. Cars with doors. Cars with steering wheels. Cars people actually bought and drove home. I don't think Waymo is incompetent. I think they were optimizing for the wrong finish line the entire time. And that, honestly, that bothers me more than incompetence would. Because incompetence is fixable. Misaligned incentives are structural. The part that's almost funny. You know what the U.S. government's official position was in 2021? Right when multiple companies were announcing commercial robotaxi launches? The official regulatory language said, essentially, current automation still requires a human ready to take control at any moment. So the companies are out there saying, the future is now. And the government is quietly saying, please keep a human in the car. Both things were true at the same time, which means the commercial robotaxi was technically a taxi, driven by a robot with a human backup, in case the robot got confused by a plastic bag blowing across the road. $12 billion. Plastic bag. Human backup. I don't know whether to laugh or file that under things that should be taught in business school. Where it gets genuinely uncomfortable. Here is the part I don't see discussed enough. Argo AI. $3.6 billion from Ford and Volkswagen. Gone. Dissolved. 2022. GM Cruise suspended operations after a pedestrian incident and what regulators described as the company withholding information. And the people who built all of this? The researchers, the engineers, the PhDs. Some went to robotics. Some went to defense tech. And some documented by U.S. counterintelligence moved toward organizations with ties to China. Not because they turned their backs on anything. Because that's where the programs were still running. Talent follows opportunity. That's not a scandal. It's a structural failure of the ecosystem that trained them. The expertise didn't disappear. It redistributed.
While the American companies were still arguing about deployment timelines, Baidu's Apollo Go in Wuhan was already running commercial rides. No safety driver. Revenue positive. It is in the size of a small city, not a demo. Actual rides, actual revenue. The country that invented this technology is now watching the country that deployed it pull further ahead every quarter. The thing I keep coming back to venture capital is brilliant at funding the demonstration. Show me something that works once, beautifully, on a closed course, in good weather, with a tailwind, and it'll give you $100 million. But manufacturing? Reliability? Edge cases at 3 a.m. on a wet road in a city where the traffic lights are from 1996? That's not a venture capital problem. That's an industrial problem. And Silicon Valley, structurally, does not do industrial problems well. Toyota took 4 years to go from research to a production hybrid. 4 years. With institutional capital, patient timelines, no pressure to have a viral product launch. The Prius wasn't announced at a TED Talk. It was built in a factory. There's a lesson in there somewhere. I'm not sure Silicon Valley is ready to hear it. The question I can't shake: if everything I just described is accurate, and the documented record suggests it mostly is, then the real question isn't when will self-driving cars arrive. The real question is, who exactly was the customer here? Because it wasn't you. It wasn't me. It wasn't the person trying to get to work in a city with no good transit. The customer was the next investor. And the investor got what they paid for, a story. The rest of us got a wait list. The underreported risk nobodies talking about the institutional knowledge built over 15 years of American autonomous vehicle research is leaving the building. Not slowly, quickly. And the places it's going aren't required to publish safety reports. If the technology that was supposed to redefine American transportation ends up deployed at scale first by a Chinese company, running on roads in a city most Americans can't name, does it matter who invented it?